Today, we're going to learn how the pop method works with a priority queue. Hello, I'm James Helfrich. The priority queue is implemented with a heap, and a heap is a data structure that ensures the topmost element is the highest element in the collection. But it does more than that. It also assures that every node in a binary tree is greater than or equal to its two siblings. So the question is, how do you pop or how do you remove the topmost element? This video will demonstrate how that works. The algorithm from pop works as follows. First, we swap the topmost element with the end element, and then we remove that end element, and then we percolate down from the root. So if I have a heap that looks like this, when I pop, I only pop the root element. So I'm going to swap 92 with 11, and then I'm going to remove 92. So now the element 92 is removed, but I'm not quite a heap. So if I call percolate down off number one, off index number one, that will restore the heap constraint. So element 11 is not greater than 89, so 89 will swap places with it. 61 is going to be the larger of the two, so we'll swap places with it. And now since 11 has no children, I'm finished and we're a heap again. Let's take a look at another example. Here I have a collection of 15 elements. I'm going to add them to my priority queue using a list using the priority queue's iterator non-default constructor. So I'll start here, and that'll drop the elements into the queue. Now, in order for me to remember the individual indices, I will put the indexes on here as well. Now, when I say pop, then I'm going to swap 99 with 52, and then remove 99. So now 52 needs to be percolated down. And once again, 89 is going to be bigger, and then 73 will be bigger. And now it looks like 52 is actually greater than or equal to 38 or 50, so I'm finished. When I'm finished, my heap will look like this: 89, 86, 73, 67, 89. Now I'm going to take that exact same code and I'm going to put it into the debugger. Now notice that when I first run the debugger, before I step into pop, then the elements are in the priority queue exactly as they were in the list. And the reason for that is because I was very careful about putting them in the correct order. Now, when I execute pop and I expand it, we'll notice that the order of the elements has changed. And now we're going to match the same order that we had when we did it by hand: 89, 86, 73, and so on. Let's go back to our output we had before and make sure that's the same: 89, 86, 73, 67. Look, they're both the same. We can learn more about how pop works by looking at the pop section of the priority queue chapter of the C++ data structures textbook.